Alright, so we're doing some heat treating tonight. Got my little electric furnace out, and the heavier part's in there right now. I'm going to put the lighter part in. This was magnetized, so I needed to demagnetize it a little bit because it was wanting to tip over as I put it in there. So we're just going to be heat treating an atmosphere, which means the atmosphere in the furnace. So we're going to warm these up. We're going to let them equalize at 1250 degrees F, and then we'll bring them up to the heat treat temperature, and in this case is 1550 Fahrenheit. This is 52100 steel here. Same stuff they make ball bearings and gauge blocks and things like that out of. And then we're going to do an oil quench, and then we'll temper it. So should be some fun. Alright guys, this thing's been soaking at 1550 for about, I don't know, 20 minutes or so. So we got our quench oil here. This is a special oil that has a kind of a engineered quenching rate. And so I'm going to open this up and grab one of the parts and quench it, and do the other one. So here we go. Do the little one first here. And you see I'm agitating it, and that's to keep bubbles from forming around the part, and so that the oil gets to it. And that's probably about it. Yep. Okay. So we'll set that one aside there. Clean the pleers, otherwise they'll smoke out when I reach in there. So that's dead hard now. We have to temper here after this. So, all right. All right, let me turn this way down here. So the vessel's slightly warm now because the oil has absorbed the heat from the part. Okay, oh yeah, scaly rider there. Yeah, it's still a little bit warm. So I don't care about the scale in this case because all these surfaces are going to get ground, so it doesn't make any difference for this situation. Okay, so we've started the tempering cycle now. We're going to temper at 400 degrees F, and we're going to leave it in there about 2 hours, then we'll air cool. So the next 2 hours of video will be very boring. Just kidding. Alright guys, I'm going to let you in on my little secret project. We were doing the heat treating a little while ago. Well, here's the parts, okay? So I bead blasted them to remove all the scalies and stuff off of it. Then I checked the Rockwell hardness, and they're about 60 Rockwell right now. What this is this is a custom Edgefinder, okay? So I'm calling this a narwhal or a Pinocchio or let's see, anteater or some kind of long-nosed creature. So the idea here is that with a small diameter tip we can reach large diameter rounds in the milling machine. I saw one like that somebody had made years and years ago, and I always wanted to try making one and lapping those surfaces and doing all that. So that's what we're doing. And there's the bits. Okay, so we're going to start with this big part. Okay, and we got the whirligig here. Okay. And so I think what we're going to do first is we're going to grind this diameter here, concentric with that. and go from there. So let me get this set up, and I'll come back in a second. I'll show you how you dial this in, and then we'll do a little cylindrical grinding on the surface grinder. Okay, so we're adjusting this to get it concentric. I want to do the shank, that way when I turn it around I don't have to, there's grinding stock on both of these diameters, but I'm going to dial it in on that one, I'll grind that one, and then I'll flip it around and grind the small diameter, okay? So you can probably see the indicators whipping around there. So now, let's see if you guys can see this. Okay, you see this little screw right here? We adjust that little screw and it moves the V-block up and down. It's on a little rack and pinion. It's a very slick setup. So let's see, where are we here? Flip it 180. Okay, so we're falling off, so I gotta go the other way. Let's, oops, too much. So when you get down in the fine adjustments, ooh, pretty good first try there. And that may be as close as we can kind of practically get it here. This is a tense indicator here. Let's see if I can get it a little closer. I'll check it side to side. Let me adjust this a little bit. Flip it around. So yeah, it's about 2/10 side to side. Okay, and then that's pretty damn good. You know what? Let's see. So that side's low, so it's got to come up. Okay. You got to think about, oops, yeah, see, sometimes it's difficult to make a real small adjustment. Like this. Creak. All right, well, you chase your tail sometimes. Oh, there we go. All right. You know what? I'm going to call that okay here for this. This is the first initial grind. So now the V-block has a locking screw. It's preloaded with a big spring in there, so it's uptight against the rotating part. Let's see if we can get this dang thing in there. I haven't used one of these in a while, so. All right, there we go. Of course, and you're doing this all up on the deck of the surface grinder, so I want to leave the indicator on it, so come on, there we go. Get in there. Okay, so that should be nice and tight. Let's give it a little spin check. Okay, so a few tenths, 3/10, something like that. Okay. All right, so I'm pretty happy with that, and then we'll come up and we'll dust off that diameter. Let's go for it. Okay, so we're kind of ready to go here. The wheel's been trued and dressed. It's got a fine dress on it, so because I'm looking for good surface finish here. You come up and we'll touch off here. All right, there's the touch off. So I'm just gonna feed it in on that touch off, because I don't know how wonky that is. Need to put a motor on this little spinner here. Take a little while. We'll down feed a half a thou or so. Give it another run. You guys will like this one. I got a little mirror here so you can kind of see it from this other angle, which is kind of cool. So let's give it a little down feed and let's go to town here. It's kind of neat, I can see it in the mirror myself. So it looks like we're grinding all the way around now. It took about a thou to clean that up. We'll take a measurement after this pass. Yeah, I can see in the V block when in the mirror when I'm getting close to the V block. Get out of the way there. All the way out. Get away from that wheel. Alright, let's see if we can get a micrometer in there. .568, okay. Oop, you won't be able to see that. 568, our target's 563, so we got a few thousandths to go. Okay, so this just goes to show you how lazy I am. I got tired of turning this dang thing, and it's, you know, it's just kind of an awkward arrangement here, in particular, because this plate is just something I had, and it's a little long. I wish my hand bumps into this as I go around, so it's kind of uncomfortable. So here's a little trick for you guys, if you need to make an expanding bushing. So this is just a Delrin bushing here that happens to fit this bore pretty nice, okay, I could put it in. But what I've done is I've tapped a pipe thread in the end, which is tapered, okay? And then I've split this bushing into the thread. And so I'm gonna drive, this is my driver here, so I'm gonna get it started. I'll push it in a little bit more, and then that's gonna expand, there it goes, okay? It's gonna expand that bushing. And then I'm gonna put a little friendly cordless drill on there, okay? So now I'm power feeding here, guys, okay? And that'll keep my arm from wearing out for your viewing entertainment, okay? So let's get back to some grinding. 5637. Okay, we're pretty close. My cordless batteries are goner. Alrighty, be right back. Almost easier to look on the damn camera there. I didn't have a super nice, you know, I'm cutting with the whole side of the wheel there. I should probably relieve the wheel a little. But it's probably fine for making it perpendicular to this surface here, and then we'll lap it. So I think we're just going to move on and do the other cylindrical part. Alright, well there's the finish for the cylindrical part. I wiped it off. I didn't polish it or anything. We're using a 32A 60 in an I hardness with a real fine, real slow fine dress. And there's the end surface there. I'm not super happy with the end surface, but I think that's just going to come out in the wash when we lap it. So should be pretty perpendicular to the cylindrical part. So we'll have to see how it goes from there. So I'm going to flip it around, and then I'm going to do this end next. For those of you that are wondering, I've modified this screw a little bit, and I don't know if you can see that. I added a little bit of silicon bronze to the tip of this steel screw. That way when I crank down on stuff like, well, it probably wouldn't mark this because this is 60 Rockwell C, But when I put other things in there, these hard screws tend to mark things. So most guys put a little copper slug under there or something like that, and but I just modified the screw and I put a little weld buildup on there in silicon bronze. So okay, so I'm going to flip it around, I'll indicate it, then we'll start buzzing that side.